Good evening, and welcome to Boring Science for Sleep. This is a place where science becomes a bedtime story, gentle, slow, and never too serious. You don't need to remember the details or follow every explanation. Just let the words drift around you like starlight, carrying you toward rest. Tonight, we wonder about something that feels almost like a riddle whispered by the cosmos. Can light ever stop moving? Light is the traveler of our universe. It spills from the sun, dances on the surface of the moon, glimmers in the stars, and enters your eyes every moment you're awake. It seems to always be in a hurry, racing through the dark at the fastest speed nature allows, as if it cannot stand still. But could it ever pause, even for a breath? Could light ever truly stop? We'll explore this question together, not as a lecture, but as a lullaby, a journey through prisms, mirrors, and atoms, through the mysteries of speed and stillness. A story of how light behaves and why it is both restless and, in rare moments, caught in quiet places. So, before we begin, tell me, where are you listening from tonight, and what time is it there? I'd love to know how far this little story travels across the world, just like the beams of light we'll be talking about. Now, settle in, let your breath slow, and let's begin our quiet journey into the mystery of whether light can ever stop moving. Close your eyes for a moment and imagine the universe as a vast, endless road. Across this road, travelers move, slow, steady planets turning, drifting comets wandering, galaxies spiraling in stately grace. Yet among all of them, one traveler is unlike the rest. It is weightless, restless, tireless. It is light. Light is never still. It does not linger in one place, does not pause to rest its feet. It rushes forward at the fastest pace the universe allows, as if the fabric of reality itself compels it onward. Wherever there is space, light is moving through it. Wherever there is darkness, light is trying to fill it. Think of the sunlight that warms your face on a clear morning. That light began its journey in the core of the sun, born in the fire of nuclear fusion. For thousands of years, those photons, tiny particles of light, struggled outward, bouncing from atom to atom deep within the sun's blazing layers. And then, finally free, they burst into the open sky and raced across the void of space at 300,000 kilometers every second. In just 8 minutes, they crossed the gulf between sun and earth, leaping 150 million kilometers to touch your skin. 8 minutes ago, that warmth was fire in the sun's heart. Now it is here, alive on your face. That is the restless nature of light. To travel, to move, to cross unimaginable distances in an instant. But the sun is not its only home. Look up at the stars, each one sending beams of light across the abyss. Some of the light you see tonight left its star decades ago, others centuries, others millennia. When you gaze at the stars, you are gazing into the past, receiving messages written long before your birth, and those messages are carried by light, the eternal traveler, delivering stories across the cosmos. Light moves not only through space, but also through time. Its speed is so absolute, so central to the laws of physics, that it defines the boundary between past and future. No signal, no object, no thought can outrun it. Light is the yardstick by which the universe measures possibility. It is the ultimate courier, the messenger that ensures one part of the cosmos can know of another. Imagine a runner in an endless race. This runner never stops, never slows, never grows tired. The track is infinite, the pace unchanging, the destination irrelevant. That is light, a runner without fatigue, a traveler without rest. Even here, in this quiet room, light surrounds you. It reflects off the walls, glows from your screen, scatters in the air. Every moment, your eyes are touched by trillions of photons, carrying with them the shapes and colors of the world. Without light, there would be no vision, no sunrise, no shimmering reflection on water, no twinkle of stars. Without light, the universe would exist, but it would remain invisible, like a book with pages no one could open. And still, it never stops moving. The instant light is created, it races outward. A flame, a lamp, a spark, all release photons that shoot into space at the same ceaseless speed. Most of them will vanish into the dark, traveling forever, long after the flame is gone, long after the lamp is extinguished. Even the smallest match can send a signal into eternity, its light moving outward endlessly, carrying the memory of its brief fire. Light does not ask permission. It does not wait. It is motion itself, the very definition of movement without rest. The universe gave it no weight, no mass, nothing to hold it down. And because of that, light cannot stop. To be light is to move. But think how strange that is. Everything else you know, rocks, rivers, planets, people, can pause, can rest, can stop. A stone can lie on the ground for 1,000,000 years. A planet can orbit slowly, patiently, without hurry. You can close your eyes, breathe deeply, and be still. But light has no stillness. It was born for motion, and motion is all it knows. This truth gives light a kind of freedom. It can cross the galaxy, slip between worlds, fall into your eyes, and continue on, never pausing. And yet, in that freedom, there is also a kind of fate, for light cannot choose to stop, cannot choose to rest. It must move, always, until something absorbs it, transforms it, or bends it away. Picture the universe as a great sea, and light as endless waves upon it. The sea cannot be still, the waves must travel. They rise, they fall, they carry energy across the water. So it is with light, waves without rest, energy without pause, travelers without home. When you walk outside under the moon, the light you see is not the moon's own, but sunlight, reflected. It traveled from the sun, struck the lunar surface, and bounced into your eyes. The moon is simply a mirror for the sun's beams, guiding the traveler to you. Every glimmer on water, every sparkle on glass, is this same journey repeated, light in constant motion, bouncing, scattering, finding its way. This restless traveler connects everything. Without light, the sun could not warm the earth, plants could not grow, eyes could not see. Light is the bond that ties us to the stars, the bridge across distance. Every photograph, every reflection, every glance between two people is a story written in light, carried on its endless journey. And yet, as constant as it is, as unchanging as it seems, the question lingers. Could it ever stop? Could this runner ever rest? Could the traveler ever pause its journey? We will follow that question in time, but for now, rest in the thought of light's ceaseless motion. Imagine photons streaming endlessly through space, carrying the warmth of stars, the glow of galaxies, the shimmer of fireflies. Imagine yourself bathed in that motion, touched by beams that began their journey long before you were born. And let that thought soothe you, that even in the vast silence of the universe, there is always movement, always connection, always light. The traveler of the cosmos, the messenger of eternity, is always on its way. Imagine, for a moment, a universe without boundaries, a canvas stretched endlessly in every direction, filled with stars and planets, clouds of dust and rivers of galaxies. Upon this canvas, countless things move, moons orbit, comets drift, planets turn. But among them all, light rushes with a speed that none can match. It is the fastest traveler in existence, and its pace is absolute, nearly 300,000 kilometers every second. That number is so large it almost ceases to have meaning. In a single heartbeat, light can circle the Earth 7 times. In a blink, it leaps from the moon to your eyes. In 8 minutes, it crosses the gulf from the sun to Earth. In just over 4 years, it travels the distance to the nearest star. Nothing else we know of can outrun it. Light is not merely fast, it is the very definition of speed. But why? Why does light move so quickly? Why is its pace not slower or faster still? The answer lies not in chance, but in the very foundation of reality. The universe itself has a speed limit, and light is the thing that touches it. Think of space as a great fabric, woven from time itself. Everything that exists, every planet, every atom, every thought, moves upon this fabric. And on this stage, there is a rule: nothing with mass can move faster than light. It is not simply a record to beat, not a high score to surpass. It is the law of the cosmos, etched into the structure of reality. The reason is subtle but beautiful. Light is made of photons, particles without mass. They are weightless, free from the anchors that slow everything else. Because of this, they do not need to push against space or gather momentum the way heavy things do. Instead, they exist at the ultimate pace allowed, the natural limit of the universe itself. It is as if the moment they are born, they are handed a single command: move at the speed of light and never change. Einstein revealed this truth more than a century ago. His theory of relativity showed that the speed of light is not just fast, it is constant. No matter where you are, no matter how you move, light always rushes past at the same pace. You could chase it at incredible speeds, and still, it would slip through your fingers at 300,000 kilometers per second. It cannot be slowed by pursuit, nor hurried by push. It is fixed, steady, eternal. Imagine trying to catch a bird that always flies just beyond your reach. You run faster, you stretch your hand, but the bird keeps the same distance, no matter what you do. That is how light behaves. It is untouchable, always a step beyond. This constancy is what makes light the ruler of the cosmos. It is the measure by which distances are calculated, the rhythm by which time itself is kept. Scientists speak of light years not as poetry, but as precision, the distance light travels in 1 year. Galaxies, stars, even the universe itself is measured in light's units. In a way, light is both messenger and metric, the thing that carries knowledge and the thing that defines the scale upon which knowledge is drawn. But there is more. The speed of light does not simply limit how fast things can move. It limits what is possible to know, to see, to experience. When you look at a star 1,000 light years away, you are not seeing it as it is now, but as it was 1,000 years ago. Light is a courier with perfect loyalty, but also with inevitable delay. It tells the truth faithfully, but only when it arrives, and it never arrives instantly. The faster it moves, the more of the universe it can connect, yet the limit remains. And so, in the stillness of the night, when you gaze upward, you are not looking at the present, you are looking at the past, stitched into the sky by light's tireless journey. The universe is a gallery of old portraits, each star a painting finished long before you were born, each galaxy a memory carried across space by beams that never stop. The speed of light is not just a number, it is the heartbeat of the universe. It decides how long a star's story takes to reach us, how wide our cosmic horizon is, how deeply we can see into the past. Without its constancy, the universe would unravel, time would twist, and cause would lose its meaning. Think of it this way. If two friends stood across a valley and called to each other, their voices would carry with the speed of sound. If one friend moved closer, the words would reach sooner. If they moved apart, the words would take longer. But with light, it is different. No matter how you move, the light always keeps its pace. It does not bend to convenience. It does not adjust to your path. It is the strictest law in the cosmos, and yet the most generous, because from that law, stability is born. This is why scientists often describe the speed of light as cosmic dignity. It is not negotiable, not fragile. It is absolute, and in its absoluteness lies the structure of reality itself. Of course, in everyday life, you never notice this. Light seems instantaneous. You flip a switch, and the room is lit. You strike a match, and the flame glows. The time between spark and sight is so small that you cannot perceive it. But when the distances grow larger, across planets, across stars, the truth becomes clear. Light is fast, but not infinite. It is quick, but not instant. That balance is important. If light were slower, the universe would be smaller to us. The sun's warmth would take hours, not minutes, to reach us. Communication across space would be impossible. If light were faster, the rhythm of time and space would shift. Relativity itself would collapse. The delicate balance of cause and effect would falter. The universe is tuned to this exact speed, as if nature chose it with infinite care. And so, we live in a world defined by this invisible runner, this cosmic courier that moves at the edge of possibility. Its pace is fixed, its journey unending. It connects us to the stars, reveals the shape of galaxies, defines the flow of time. It is the fastest thing there is, and yet, in its speed, there is patience too. For while it moves quickly, The distances it crosses are so vast that its messages arrive with gentle delay. The stars we see are already memories, and yet their light feels immediate, intimate, like whispers carried across centuries. As you rest tonight, think of light not just as brightness, but as motion itself, the restless traveler who obeys a single law. It cannot be slowed, cannot be hurried, cannot be outrun. It is the speed of the universe, the measure of all journeys, the limit beyond which nothing can pass. And perhaps, in its constancy, there is a lesson for us, that some things in life are not to be rushed or altered. Some things simply are. The speed of light is not negotiable, and yet it gives us everything: the warmth of the sun, the beauty of the stars, the glow of the moon. In its steady, unchanging pace, the universe finds its order, and we find our place within it. Let that thought settle in your mind like a soft glow, that light moves as fast as the universe allows, and that this speed is not chaos, but balance. The cosmic speed limit is not a cage, but a framework, one that gives us time, distance, memory, and meaning. Rest now, under the quiet truth of that law. Light is moving, always carrying the stories of the cosmos to your eyes. It will still be moving tomorrow, and the day after, and for as long as the universe continues. It is the fastest traveler, the patient messenger, the endless beam in motion. Imagine the universe as a vast stage, upon which every actor plays a role. Planets turn, stars burn, galaxies swirl in their grand spirals, and then, across this stage, there is light. But unlike the others, light has no costume, no weight, no anchor. It is pure motion, energy in its purest form. To be light is to move. To be light is to never rest. Most things in the universe are made of matter. Stones, rivers, clouds, you and I, everything we can touch has mass, a kind of weight that ties it to the stage. Matter can be at rest. A rock can sit motionless on the ground, a planet can pause in balance between forces, even a person can close their eyes and remain still. Rest is the privilege of matter. But light is not matter. Light is energy, and energy does not sit still. At its heart, light is made of particles called photons. They are strange little things, without mass, without charge, without the anchors that hold everything else in place. A photon is not a rock, not a pebble, not even a grain of dust. It is closer to a whisper of energy, a ripple through space, a wave that must travel the moment it exists. The moment a photon is created, whether in the core of a star, in the spark of a fire, or in the glow of a screen, it immediately takes flight. There is no pause, no hesitation, no lingering. Because with no mass, there is nothing to slow it down, nothing to make it rest. The laws of physics demand that it move at the speed of light. For photons, motion is not a choice, it is their very definition. Think of a dancer who has forgotten how to sit. They may spin, leap, twirl endlessly, but they can never stop and rest upon the floor. To stop would be to cease existing. That is the photon, a dancer in eternal motion, whose rest state is simply not being at all. And yet, we often talk about light as if it could be still. We speak of light filling, a room of light resting upon the surface of water, of light caught by our eyes. But these are only metaphors, shadows of what is truly happening. In reality, the photons are always moving, striking surfaces, scattering, reflecting, absorbed and re-emitted in endless dances. They are not still. They are always traveling, even when we think they have paused. This restlessness comes from energy itself. According to Einstein's famous equation, E equals mc squared, energy and mass are related, two sides of the same coin. Matter can rest because its energy is stored in mass, but photons have no mass. All of their being is in their motion. For them, to be energy is to be movement. They cannot transform into stillness. Stillness would erase them. Imagine a river, endlessly flowing. You could block it, divert it, freeze it into ice, but as long as it remains water in liquid form, it must move. That is light, a river of energy, streaming across the universe, incapable of rest because its essence is motion. Even time behaves strangely for light. For us, time flows forward second by second, heartbeat by heartbeat. But for photons, time is meaningless. Because they move at the speed of light, they do not experience time at all. From the moment a photon is born to the moment it is absorbed, no time has passed in its own frame of reference. For the photon, the journey is instant. This is why it cannot rest. Rest would require it to experience time, to linger, to endure. But light knows only the immediacy of motion. If you think of light as a messenger, this truth becomes clearer. The photon is a courier, carrying energy from one place to another, from the sun to earth, from a candle to your eye, from a star to the deep of space. If the courier stopped, the message would never arrive. And so the courier never stops, never rests, never delays. It is always moving, always delivering. This is why the world around us is visible. Every color you see, every object you recognize, every shape and shadow exists because photons are constantly streaming into your eyes. They bounce from walls, from leaves, from skin, carrying with them the information of color and brightness. They are tireless messengers, billions upon billions arriving every second, painting your vision. If photons could rest, the world would dissolve into darkness, shapes would vanish, and sight would end. And yet, the strangeness of light is that it is both particle and wave. At times it behaves like a stream of tiny bullets, striking surfaces one by one. At other times it behaves like ripples on a pond, spreading, overlapping, interfering with one another. Scientists call this the wave-particle duality. But whether wave or particle, light shares the same truth. It is motion. The wave moves, the particle moves. Both are energy, and energy cannot stop. Perhaps this is why light has always been a symbol of spirit, of vitality, of life. From fire worshippers of ancient times to the poets who called love a flame, light has been seen as something beyond stillness, something that stirs, inspires, ignites. In science, we now know why, because it literally cannot be still. It is a physical truth, but also a poetic one. Think again of the Sunday. Every second it releases billions of photons, streams of energy flying outward in all directions. Some will touch planets, some will vanish into deep space, some will strike your skin, but none will rest. The moment they are born, they are travelers. The sun does not just shine, it sends forth endless rivers of restless energy, filling the universe with motion. Even in the quietest places, in the darkness between galaxies, light still moves. Ancient beams, born billions of years ago, still journey outward, carrying with them the story of stars long extinguished. They will never pause, never stop, unless absorbed by some lonely particle in the void. The darkness of the cosmos is not emptiness. It is filled with silent rivers of light, always moving, always carrying. And so, to ask if light can rest is to ask if energy itself can sleep. The answer is no, not in the way we know rest. Light is existence in motion. Rest would undo its very nature. But perhaps, in its ceaselessness, light offers us a kind of comfort. It shows us that movement does not always mean rushing, that restlessness can also be beauty. The light of a candle, flickering gently in the night, is not frantic. It is calm, steady, soothing. Its photons are moving at unimaginable speeds, and yet to our eyes it feels peaceful. The dance of energy becomes our sense of serenity. So as you lie here tonight, think of light not as hurried, but as faithful, a messenger that never stops, because to stop would be to vanish. A dancer that spins eternally, because the dance itself is its existence. A river that flows forever, because flow is its only form. And let that thought cradle you, that even the most restless thing in the universe can bring stillness to us. That light, in its endless energy, creates the calm by which we see, the warmth by which we live, and the beauty by which we rest. We have been following light as a restless traveler, always moving, always racing at the fastest pace allowed by the universe. But even the fastest travelers sometimes appear to hesitate. And though light itself cannot rest, there are moments when it seems to slow down, caught for a time in the embrace of matter. Imagine a beam of sunlight striking the surface of a lake. To your eyes, it glimmers and scatters, rippling across the water in flashes of silver. Beneath the surface, however, something curious is happening. The photons enter the liquid, and suddenly their journey seems less swift. Instead of moving at their usual cosmic pace, they take longer to cross. It is not that they have lost their energy, nor that they have grown tired. It is that the path has become complicated. Light in a vacuum, the emptiness of space, travels straight and unhindered, but in water, glass, or crystal, it must weave between atoms, navigating a crowded dance floor. Each photon still moves at the speed of light in the empty spaces between atoms, but it does not get a clean run. It is absorbed by an atom, then re-emitted, again and again, a million tiny handoffs. To us, watching from the outside, it looks as if the light has slowed. In truth, the traveler is still sprinting, but it is forced to pause at each station, to hand over its energy, to wait before resuming. Think of a runner weaving through a busy marketplace. On an open road, the runner could dash unhindered, but in the crowd, every step is slowed by detours, sidesteps, pauses. The runner's speed has not changed, only the path has become tangled. That is light in water, in glass, in crystals. This slowing gives rise to some of the most beautiful phenomena we know. A straw dipped in a glass of water appears bent, as if broken. A prism splits white light into a rainbow, slowing each color differently so that they spread apart. A diamond catches beams of light and scatters them into brilliant sparks, each angle a reminder of how photons hesitate inside the lattice of carbon atoms. It is as if matter and light are partners in a slow waltz. The atoms take the photon's hand, spin it, release it, then another atom catches and spins again. The photon is always moving, but its forward progress is delayed, transformed into a graceful dance instead of a direct sprint. This is why light bends when it enters water or glass. Its apparent speed is reduced, and with it, the angle of its journey shifts. To your eyes, the world behind the surface looks bent, shimmering, strange. You are seeing not a trick, but the natural consequence of light's slowed path. In crystals, this dance grows even more intricate. The atoms are arranged in repeating patterns, like a floor of tiles perfectly aligned. Light moving through such a lattice interacts with this geometry, slowed and scattered in ways that can trap it, redirect it, or even hold it for a moment. Engineers use these properties to shape lasers, to build fiber optics, to bend beams with exquisite precision. The slowing of light is not only beautiful, it is useful. But what does this tell us about our question? Can light stop moving? Not quite. Even in water, even in glass, the photons themselves never lose their restlessness. They always move at their universal speed when between atoms. What slows is the effect, the average pace of their progress. It is like watching traffic on a busy road. Each car moves quickly when free, but constant stops and starts make the journey longer. The cars never stop being cars. The photons never stop being light. This slowing allows for wonder. Without it, there would be no rainbows arcing across the sky after rain. The droplets of water scatter sunlight, slowing it and spreading its colors into a fan of red, orange, yellow, green, blue, indigo, and violet. Without it, there would be no sparkling play of light in cut glass, no stained glass windows glowing with colored brilliance, no shimmering refractions in crystal chandeliers. Light, in its slowing, reveals its hidden complexity. White sunlight is not pure, but a symphony of many colors, each with its own speed inside matter. Red is slowed less than violet, and so the rainbow spreads wide. The slowing teaches us that what appears simple is, in truth, infinitely layered. Perhaps there is a lesson in this too. Sometimes in life, we feel slowed, delayed, caught in obstacles. Yet, like photons in water, we are still moving, still carrying energy, still progressing, even if the path is not direct. The slowing does not end the journey. It transforms it, creates beauty, reveals hidden colors. Scientists have even learned how to slow light dramatically. In carefully prepared crystals or ultra-cold gases, light can be made to crawl at mere kilometers per hour. In some extraordinary experiments, it has even been halted completely, its information stored in matter, like a song written down, to be released later, as moving light again. For a moment, light seems caught, held in suspension, and yet it is not truly at rest. Its energy is simply waiting, transformed, until it can resume its endless journey. So, when you see a prism or a rainbow or the sparkle of glass, you are witnessing this strange compromise. Light cannot stop, but it can appear to slow, weaving its way through the lattice of matter. It is still the restless traveler, but the path becomes a winding road, a dance, a hesitation that brings forth color and wonder. As you rest tonight, imagine yourself as a photon entering water. Outside, your path is swift and straight. Inside, you are passed from hand to hand, delayed, bent, slowed. And yet you are never still, never at rest. You emerge transformed, separated into colors, shining in ways you could not before. Slowness, then, is not loss, it is revelation. And in that thought, perhaps you can find comfort, that even the fastest thing in the universe is sometimes slowed, that even restless light must sometimes weave and wander. That slowing can be beautiful, can create rainbows, can reveal truths hidden in white brilliance. Let yourself slow now, too. Let your breathing ease, your heartbeat soften, your thoughts scatter like light in a prism. There is no need to rush. Like light in water, you are still moving, still alive, even when the pace feels gentler, and in that gentleness, beauty waits. For most of history, light seemed untouchable. It was the very symbol of freedom, slipping through cracks, bouncing off mirrors, pouring across distances that no creature could cross. How could one ever hope to hold light? To grasp it in your hand, to command it to stay still, seemed as impossible as catching wind in a jar. And yet, in the quiet halls of laboratories, with lasers humming and crystals glowing, scientists have dared to do just that, to catch the beam, to slow it, even to stop it for a heartbeat of cosmic time. Let's begin with the late 20th century, when physicists first began asking, can light be tamed? They knew photons were restless messengers, racing at unimaginable speeds, but perhaps, under the right conditions, their information could be stored. If you could not freeze the photon itself, maybe you could pause the song it was carrying. The key was in matter, specifically, matter prepared in unusual states. Ordinary glass or water could slow light somewhat, but not enough to truly catch it. To go further, scientists turned to gases cooled to nearly absolute zero, where atoms no longer jitter with heat, but instead align into delicate quantum states. These ultra-cold clouds, called Bose-Einstein condensates, became the stage upon which the daring experiment could unfold. In 1999, physicist Lena Howe and her team at Harvard astonished the world. Using a cloud of sodium atoms chilled to billionths of a degree above absolute zero, they sent a pulse of light into the mist. And something magical happened. The pulse slowed to just 17 meters per second, about the speed of a bicycle. Light, the eternal sprinter, had become a pedestrian. For the first time, humans had watched the fastest traveler in the universe crawl. But Howe's team didn't stop there. By tuning the interactions between the atoms and the photons, they found a way to halt the light entirely. A pulse entered, vanished, and its information was imprinted on the atoms themselves, like a message folded into a letter and tucked into a pocket. Later, the atoms released the information, recreating the light pulse. The beam was caught, stored, and released again, as if time itself had paused for light. It was not that the photons themselves had stopped existing. Rather, their energy, their pattern, their identity had been woven into the dance of atoms. The messenger had vanished, but the message remained, waiting to be called forth again. Imagine a bird in flight, its song ringing out. If you could somehow catch, not the bird but the song itself, hold the melody in the air, pause it, then let it fly again, you would understand what Howe and her colleagues achieved. Other scientists followed. They experimented with crystals, with exotic materials, with carefully prepared conditions that allowed light to be slowed, bent, twisted, stored. Photonic information could now be trapped, making it possible to dream of quantum computers, of communication systems that hold light as memory, of technologies that one day may seem like science fiction made real. The act of catching light was not only technical, but philosophical. For thousands of years, light had been a symbol of the uncatchable, truth, spirit, freedom. And now, in the silence of cryogenic labs, humans had touched it, guided it, persuaded it to linger. But what does this mean for our great question? Can light stop moving? Not exactly. The photons themselves never rest. What stops is the wave they carry, the pattern of energy and information that can be mapped onto matter. It is as if the dancer has left the stage, but the choreography remains written down, ready to be performed again. The energy waits in another form, another body, until it can leap back into motion. And yet, even knowing this, there is something poetic about those experiments. Scientists standing in cold labs, peering into glowing mists, watching the heartbeat of the universe hesitate for a moment. Watching light, the restless traveler, pause in its endless journey, just long enough for us to say, "We held it." Think of what it must have felt like for those scientists. The hum of machines, the blue glow of lasers scattering in the mist, the delicate balance of atoms and photons. And then, on a screen, the pulse of light slows, and finally disappears, resting invisibly in the embrace of atoms. The room must have felt, for a moment, like a church, a place where something sacred had happened. And so, catching light became not only an achievement of physics, but of imagination. It showed us that even the most impossible-seeming ideas, holding a beam of light, can, with patience, become real. This slowing and stopping of light has also reshaped how we think about the universe. If light can be stored, manipulated, woven into matter, then perhaps the boundaries between energy and matter, between motion and stillness, are more fluid than we once thought. Perhaps, at the deepest level, everything is a dance of transformations, energy becoming matter, matter becoming energy, light becoming memory, memory becoming light again. Even now, scientists continue to explore these ideas. They experiment with quantum entanglement, where photons share states across distance. They create optical traps that hold beams in loops, bouncing back and forth for ages. They dream of storing light like a book in a library, to be opened and read at will. But still, the truth remains, the photon itself cannot stop. To be light is to move. The only way to still it is to let it become something else. Energy written into matter, information carried by atoms. The messenger vanishes, the message remains. As you drift towards sleep, imagine yourself as one of those scientists. In a room of humming machines, you hold your breath. You send a pulse of light into the mist. And then, miraculously, it slows, it halts, it waits, as if the universe itself has agreed to pause for you. You stand in silence, watching the impossible become real. And when the light is released again, continuing its journey, you smile, because you know that even if it cannot rest forever, it can, for a moment, be caught, and that is enough. So, too, in our lives, we cannot stop the passage of time or the flow of days, but we can catch moments, pauses of beauty, fragments of love, breaths of stillness, and hold them, like scientists holding light. Not forever, but long enough to remember, long enough to matter. In that sense, perhaps, we are not so different from the photons, always moving, always carrying our energy forward. But sometimes, with care, with patience, we allow ourselves to be caught by memory, by love, by rest. And in those pauses, the world becomes beautiful. If you've ever watched the evening sky, you've seen light that seems timeless. The glow of the moon hanging steady above the trees, the stars shimmering in place, the soft golden lamp of a candle flame that hardly seems to move at all. Light, in these moments, feels still, calm, patient, frozen in its quiet role. And yet we know the truth. Photons are racing in all directions, each one moving at the fastest speed the universe allows. So why does it so often appear as if light is at rest? This is the paradox of perception. Light never ceases in its journey, but to our human senses, it often feels steady, even motionless. What we witness is not the motion itself, but the lasting impression it leaves, the unbroken stream of photons arriving one after another, so seamlessly that our minds interpret it as something constant. Think of a waterfall. Each droplet is in freefall, rushing downward, yet from a distance the cascade looks like a single shimmering sheet of water. The illusion is born from continuity, the replacement of one droplet by another so quickly that you never notice the individual travelers. Light, too, is like this. The candle flame seems to hover, its glow fixed in place, when in truth it is being constantly renewed by countless photons spilling outward faster than you can ever measure. Your eyes themselves add to this illusion. The human retina does not capture a photon and forget it instantly. Instead, there is persistence, an afterglow of vision, like a memory that lingers a fraction of a second. It is this persistence that allows film projectors and televisions to work. They flash images at you frame by frame, but your mind blends them into smooth motion. In the same way, the countless photons that strike your eyes from a steady flame blend into a picture of stillness. Light is rushing, but your mind interprets constancy. Another reason for this illusion lies in distance. The sun is nearly 150 million kilometers away, yet it appears to sit calmly in the sky. What you see is not a restless swarm of photons arriving with impossible speed. It is the calm circle of a star, serene and unmoving. The photons left the sun about 8 minutes ago and now arrive in a flood so steady that their individuality is lost. Distance smooths their arrival, turning frantic motion into gentle presence. This illusion becomes even stronger when light reflects or refracts in stable ways. A mirror on the wall seems to hold an image, a frozen reproduction of your room, yet the light forming that reflection is renewed every instant. The photons bounce off surfaces, into the mirror, into your eyes, each one gone forever once it has arrived. And yet, because they do so endlessly, you see stillness instead of change. Crystals, too, can give the illusion of light trapped in place. Sunlight glinting on a diamond seems like a frozen spark. The glow of a stained glass window seems held inside the glass. But in truth, photons are rushing in, slowed by the material, redirected, scattered, and emerging in brilliant colors. They never stop, but the unbroken replacement of one with another makes them seem eternal. There is also the mystery of cosmic stillness. Stars twinkle because of Earth's atmosphere, but many of them appear steady. Their light has traveled for hundreds, thousands, even millions of years to reach us. By the time it arrives, its journey is so vast that its motion feels like permanence. A star's glow in the night sky is both an arrival and a farewell, the final step in a voyage that began long before your life. And yet, as you look, the light feels like something fixed, patient, resting in place. Science teaches us that these illusions come from repetition, persistence, and perception, but there is poetry in this too. Sometimes in life, the things that move the fastest appear the most still. A hummingbird's wings blur into invisibility, creating the illusion of a hovering bird. A spinning wheel becomes a solid disk in our vision. And light, racing at 300,000 kilometers per second, seems like something calm, something eternal. Perhaps that is why light has always been a symbol of stability. Ancient fires burned through the night, their flames giving comfort precisely because they seemed unchanging. The sun's rise each morning is the most reliable event of all, though it is driven by the restless motion of photons racing across space. Even the moon's gentle glow is only the reflection of sunlight, a stream of photons bouncing to us, replaced endlessly, and yet it feels like the most serene of companions. The illusion of stillness is not a mistake, it is a gift. If we could perceive every photon, every instant of motion, the world would be chaotic, a blur of endless activity. Our minds soften the flood, blending motion into calm presence, turning restlessness into serenity. We do not see each photon of starlight, we see the star. We do not see each flicker of flame, we see the candle. We do not see the constant renewal of sunlight, we see the morning. There are times, however, when we glimpse behind the curtain. Long exposure photographs of the night sky reveal star trails, curved lines marking the motion of Earth beneath them. Sparkler lights drawn in the dark leave streaks in photos, showing paths that our eyes miss. Fiber optics carrying signals can be slowed, bent, and trapped, revealing light's restless journey. Science lets us see the motion beneath the stillness. And yet, When we return to simple sight, we find comfort again in the illusion. So, does light ever stop moving? The truth is, no. It never rests, never halts, never lingers. But to us, it so often appears to pause, and in that appearance we find peace. Think of your own life. How often do you move constantly, carrying energy, chasing tasks, rushing? And yet, to others, you may appear steady, calm, serene, because motion, when endless, looks like stillness from afar. A life filled with moments of motion can look like stability to those who watch. As you lie here tonight, imagine yourself as a flame. Countless photons stream from you, carrying energy, carrying light. To the outside world, you look calm, still, glowing with patience. But inside, you are always moving, always alive, always restless. Stillness is not the absence of motion. It is the blending of motion so constant, so seamless, that it feels eternal. And in that thought, perhaps you can find rest. Light never stops, yet it appears still. You too may feel restless inside, but to the world, your presence is steady, your glow unchanging, just like the candle, just like the stars. So let the illusion comfort you. Let yourself appear still, even as you breathe, even as your heart beats, even as your thoughts drift. You are never truly at rest, but tonight you can seem so. And that is enough. There is another way the universe seems to pause the restless traveler we call light. Not through crystals or glass, not through the delicate experiments of scientists with lasers, but through something more ancient and immense. Gravity. Gravity, that quiet sculptor of the cosmos, does not only hold planets in orbit and pull tides across the seas, it also bends light itself. Imagine space as a soft fabric, invisible yet real, stretched beneath everything that exists. When something heavy sits on the fabric, a planet, a star, a black hole, the surface curves. And light, though massless, must follow the curves. It cannot resist the geometry of the universe. This bending of light, known as gravitational lensing, makes the universe a cosmic mirror. Distant galaxies appear stretched, duplicated, or ringed around massive clusters of matter. It is as if light has been caught, forced to linger, drawn into paths it did not intend. For us, peering through telescopes, these distortions reveal not only the light itself, but the invisible mass that shaped it, dark matter, hidden structures, cosmic giants we cannot otherwise see. But gravity does more than bend light. At its most extreme, near black holes, it can trap it. Black holes are the densest secrets the universe holds, regions where gravity grows so strong that nothing can escape, not even light. Cross the event horizon, and photons themselves are prisoners, circling inward forever. To us, it is as if light has vanished, erased from the stage. But in truth, the photons continue their journey, spiraling into darkness, unable to return. The fastest traveler in the universe, finally outmatched. And yet, even before the horizon is crossed, light begins to show the strain of gravity's grip. Around a black hole lies a special boundary, a place where photons can orbit endlessly. It is called the photon sphere. Here, light does not race freely into the cosmos, nor does it fall immediately into the abyss. Instead, it circles in a perfect loop, a cosmic racetrack where speed meets gravity in delicate balance. From afar, we would see this as a glowing ring, the shadow of the black hole, edged with light that cannot quite leave. Think of that for a moment. Light, which we imagine as the purest symbol of freedom, endlessly circling, unable to break free, caught in gravity's embrace. It is still moving, yes, but trapped in a loop, like a song stuck on repeat. For all its speed, it cannot escape. This too is an illusion of stillness. The ring around a black hole appears steady, a halo of light frozen in place, but each photon is racing at unimaginable speed, orbiting in tight curves. What you see is not stasis but repetition, not rest but confinement, stillness and motion, blurred into one. Even outside black holes, gravity slows light's escape. Near massive stars, the energy of light is sapped by the pull of gravity. Its wavelength stretches, its color reddens, as though time itself runs slower near the star's surface. To us, watching from afar, the light appears altered, wearier, delayed in its climb out of the star's grasp. Gravity holds it, not completely, but enough to change its voice. In this way, gravity becomes the great rival of light. The fastest speed in the universe meets the deepest well in the universe. And when they confront one another, light is bent, slowed, redshifted, trapped. For us, this is more than theory. It is something we can see. When astronomers gaze at distant galaxies, they find them smeared into arcs by the gravity of clusters that lie between. They find multiple images of the same galaxy, split by the cosmic mirror. And when they looked, for the first time, at a black hole with the Event Horizon Telescope, what they captured was not the hole itself, but the halo of light, the photons trapped, circling endlessly, painting the boundary of the abyss. To sleep beneath such knowledge is to rest in awe. The universe holds paradoxes like dreams. Light, which can never rest, appearing to pause in the grip of gravity. Gravity, which is invisible, made visible by the way it bends light. It is as though the cosmos itself is whispering riddles. The free becomes trapped, the fastest becomes delayed, the invisible becomes seen. Think again of the candle flame. Its light seems still, though it races outward. Now, scale that thought up to galaxies. The arcs of lensed light seem frozen, though each photon is on a curved path rushing past clusters of dark matter. The ring around a black hole seems steady, though every particle of light is in desperate motion. Stillness is never what it seems. And perhaps there is comfort in that. Sometimes in life, what feels like being trapped is, in fact, just another form of motion, circular, repeating, but alive nonetheless. Sometimes what appears still is really filled with movement beneath the surface. A life that feels paused may still be flowing. A heart that feels held by gravity may still carry light. As you lie here, drifting between waking and sleep, imagine light at the edge of a black hole. Imagine it circling, endlessly, in the photon sphere. It cannot leave, but it cannot vanish either. It remains, painting a ring of fire in the darkness, an eternal reminder that motion never truly ends. In that vision, there is peace, for even when caught, even when bound, light never stops, and neither do you. Your breath continues, your heart continues, your thoughts wander on. Rest may look like stillness, but it is motion of a gentler kind. So, let yourself be the light tonight. Let gravity hold you, let the bed be your cosmic mirror. Even if you feel caught in place, remember, the journey continues, quietly, endlessly, in ways you may not see. When you look at the night sky, you are never seeing the present. You are gazing into a gallery of memories, a frozen archive made of light. Every star, every faint glow, every smudge of galaxy is not how it is now, but how it once was, when its photons began their journey. The sky above is not a window but a record, a luminous diary written by beams that have been traveling across unimaginable spans of space and time. This is one of the most humbling truths of the cosmos. Light is both messenger and memory. It carries not only energy but also stories, snapshots of what was. The moon, serene and silver, shines with sunlight that left it a single second ago. The sun itself glows with light, born 8 minutes before you see it. A nearby star like Sirius sends photons that began their journey just over 8 years ago, and the galaxies, spiraling in faint clusters, their light is millions, sometimes billions of years old. To see the universe is to look into its memory. In a sense, light is the great archivist. Unlike sound, which needs air, or touch, which fades instantly, light preserves a record of where and when it was born. Once set free, photons move unstoppably until they strike something, your eye, a camera, a leaf, the surface of a planet. Until that moment, they carry a perfect memory of their origin. Look at a star, and you are reading its past. Look at a galaxy, and you are reading prehistory, long before Earth was what it is now. The James Webb Space Telescope and Hubble before it are not just observatories, they are historians. With their mirrors and detectors, they gather frozen echoes, bits of light that left their home when dinosaurs walked Earth, when oceans first formed, even before life began. Those photons have traveled all this time, unbroken, unhurried, until finally they are caught, measured, and turned into an image for us to see. And here is the wonder. When we speak of light being still, what we often mean is this permanence of record. A painting ages, a song fades in the air, but the light of a star, once freed, holds its truth until the very instant it arrives. It is motionless in the sense that it does not change itself. Photons cannot decay, cannot crumble into dust, cannot rewrite their own past. They are frozen pieces of memory, loyal until the end. Think of the pale light from Andromeda, our nearest large galaxy. It takes over 2 million years for that light to reach us. Each photon you see tonight from Andromeda began its journey when the first humans had yet to appear, when Earth was home to entirely different species. And yet, across all that distance, that echo has remained intact, as if time itself wrapped it in glass. You are not seeing Andromeda as it is, you are seeing it as it was, 2 million years ago. The light is the record. Even closer examples remind us of this. Lightning flashes, and a moment later thunder follows. The sound is the present, slow and lumbering, while the light is instant, already gone, leaving behind only a memory. The night sky, in this way, is a library of such memories, written in silence. There is something deeply poetic about this. In our own lives, memories fade. We try to hold them, but they blur with time, softened by distance. Light, however, does not forget. It keeps the shape of the star, the swirl of the galaxy, the flare of the supernova, carrying them faithfully until they reach another shore. To study light is to study a kind of perfect memory, a frozen echo of something that once lived. But like all archives, this one comes with limits. If a star has already died, its light may still be arriving. We see ghosts in the sky, stars long gone yet still shining, because their photons are still on the way. What we call the present sky is stitched together from the past, an illusion of immediacy created by echoes. This is not stillness but latency, the delay of motion stretched so far that it feels eternal. Perhaps this is why light comforts us. The glow of a flame feels steady, but it is really countless photons replacing one another. The glow of stars feels eternal, but it is really countless photons completing ancient journeys. Light reassures us with illusions of permanence, yet behind it all lies endless change, endless release, endless renewal. The idea of light as memory also explains why astronomers sometimes say telescopes are time machines. When they peer further out, they peer further back. Each increase in distance is an increase in age. At a certain scale, telescopes no longer show galaxies as they are, but as they were billions of years ago, just after the universe itself began. In this way, photons carry not just local memories, but the earliest pages of cosmic history. The faint glow of the cosmic microwave background, the afterglow of the Big Bang, is the oldest light of all, a frozen echo from nearly 14 billion years ago. It whispers of a universe just born, a universe still glowing from its own beginning. What then does this teach us? That light, which we thought of as restless, untouchable motion, is also permanence. It is both the fastest traveller and the most faithful recorder. It never stops, but it also never forgets. It shows us that movement and memory are not opposites but companions. And in this lesson, there is a quiet comfort. Your own life is filled with moments that rush by, yet some of them leave echoes, memories in others, traces in places, stories that will be told later. Like photons, the things you do may travel farther than you know, carrying pieces of you into futures you will never see. As you drift into sleep, imagine yourself surrounded by this frozen light. Each star above your roof is a memory, each glimmer a story preserved. The universe is not silent, it is filled with echoes, waiting for someone to listen. Tonight, you are part of that listening, catching photons that left their homes long ago. In your eyes, in your heart, in your rest, you carry them forward. So, close your eyes and let those echoes surround you. You are safe in their light, sheltered by their memory. Tomorrow will bring new photons, new journeys, new records of the world as it is. But tonight, let yourself rest in what has already been written. For light never stops moving, and yet it never lets go of the past. And in that paradox, you find your calm, the comfort of knowing that nothing, not even the fastest traveler, is ever truly lost. There is something haunting in the question: if light is forever in motion, does it ever die? Can a photon once born truly end? Or does it simply go on, endlessly, until it finds something to rest upon? The answer, like so many things in the cosmos, is both simple and profound. Light does not age the way we do. It does not tire or weaken, does not wrinkle or fade within itself. A photon, once created, will keep moving at the speed of light for eternity, unless it meets matter. Only then does its story shift. Only then does its flicker conclude. Imagine it this way: when sunlight falls on your skin, those photons end their billion-year journey from the heart of the Sunday. They are absorbed, transformed into warmth, into tiny motions within your cells. Their flicker does not vanish, it becomes part of you. When starlight touches a leaf, photosynthesis begins, and the energy of those photons is captured and turned into life. Again, not an ending, but a change of form. This is the first truth about the last flicker. Photons do not die in emptiness. They die only in encounter. And yet, that encounter is not destruction but transformation. Energy cannot be lost, only shifted. What looks like an ending is always a beginning in disguise. Now, picture the universe not as empty, but as a great theatre filled with countless curtains. Each star, planet, grain of dust is a curtain where photons may end their travel. Many wander for only moments before meeting one. Others, like the photons of distant galaxies, may cross billions of years before finally finding a destination: your eye, your telescope, your quiet night under the stars. But there is another possibility, darker and more mysterious. Some photons never meet a surface. They slip through vast stretches of space, beyond galaxies, beyond clusters, into the cold, expanding wilderness of the cosmos. There, no curtain waits, only distance growing ever wider. These photons may never be absorbed, never be transformed. Do they then last forever? In one sense, yes. A photon in the great void may continue without end, racing through the fabric of space. But as the universe expands, their energy stretches thin. Their wavelength grows longer, their light reddens, until it drifts beyond visibility, into radio waves, into whispers too faint to notice. They are not destroyed, but they are diluted, fading into the background hum of the cosmos. This is the cosmic microwave background, the oldest light we know, the afterglow of the Big Bang itself. Those photons have not ended. They are still here, washing through us every second, but stretched and softened until they are little more than a faint radio static. Their last flicker is not death, but silence. In this way, photons remind us of candles. A flame seems to vanish when blown out, but its heat remains in the air, its smoke carries its memory. Light's last flicker is never a disappearance, only a dispersal. It continues as warmth, as chemical change, as faint vibration, becomes part of something else. And yet, we speak of light as ending because we perceive its absence. Night falls, stars are hidden by clouds, a flame is snuffed out. To our eyes, light is gone. But really, it has only changed rooms. It has only taken another form, left its record in another place. The photon that once touched your cheek may now be moving through the air. The photon that once lit your book may now be bound into the motion of atoms. Nothing truly ends. It only reshapes. What then about the ultimate future? Cosmologists ask. In the far, far future, will light still exist? In trillions of years, when stars have burned out, when galaxies have grown dark, will there be photons left? The answer is yes, but weaker, stretched thinner by expansion. The universe will be colder, quieter, but the ghosts of photons will remain, drifting endlessly. The last flicker is not an instant, it is a slow unwinding, a fade into vastness. And in that thought, there is an echo of our own lives. We, too, are like photons, born, moving, meeting, transforming. Our moments seem to end, but their energy remains, in memory, in influence, in the ripples we leave in others. The last flicker is never truly an ending. Think of a sunset. The light fades, but not because it has died. It has only moved, folded beneath the horizon, changed into night's softer tones. Think of a candle. The flame ends, but its warmth lingers in the room. Its glow lingers in your eyes. Think of the stars. Many you see tonight are already gone, yet their photons still travel, still deliver their record to you across impossible time. So, can light truly end? The honest answer is no. It can be absorbed, stretched, hidden, transformed, but never erased. Energy persists, finding new shapes, new stories. Even the faintest flicker is only the beginning of another form. And perhaps that is why the idea of light comforts us so deeply. It teaches us not to fear endings. What looks like the last flicker is only the start of something unseen. Just as photons become warmth, life, or whispers of radio static, so do our own stories continue in ways we may never fully know. As you close your eyes tonight, imagine yourself as light. You travel, you move, you touch, you transform. One day you may flicker, but you will not end. Your energy, your presence, your essence will echo elsewhere, becoming part of something new. Rest in that thought. The last flicker is never the last. It is only the next step in the great unfolding of existence. You've walked alongside beams and echoes, followed photons through time and glass, across oceans of space, and into the soft silence of memory. And now, as we come to the final chapter of tonight's journey, it's time to pause and reflect. To let the story settle like twilight, and discover what light, restless, tireless, ever-moving, teaches us about the stillness we long for. For all its swiftness, light also embodies patience. It never rushes, though it always moves at the fastest possible pace. It never demands, though it fills every corner of space it enters. It never rests, yet it teaches us rest, by reminding us that even motion can feel serene when it flows without resistance. When you stand in the sunlight, you are wrapped in photons born in the heart of the sun millions of years ago, only now reaching you. They did not hurry, they simply traveled, step by step, until the journey was complete. In their presence, you feel calm, not because they are still, but because their movement is steady, unbroken, eternal. That is the first lesson light offers. Stillness is not always the absence of motion. Sometimes, stillness is the feeling of a rhythm so constant, so reliable, that it soothes you like a lullaby. The stars shimmer, the moon glows, the dawn comes every morning, because light never stops moving. Yet it feels like a rest, a promise that the universe keeps. Another lesson is memory. Light never forgets where it has been. It carries the past into the present, giving us a universe that is not fleeting but recorded. And in those records, we learn that nothing vanishes completely. Just as photons become warmth, reflection, or the curve of a shadow, so too do our own lives continue in echoes. In memory, in stories, in the soft presence we leave behind. And perhaps this is the heart of stillness, the knowledge that we don't need to cling because nothing is ever truly lost. Even the last flicker of light is not an ending. It is only a transformation. When you let go into sleep, you are not erasing yourself. You are simply entering another form of being, softer, quieter, woven into dreams. The third lesson light offers is humility. In the grand stage of the cosmos, light is not a spotlight shining on one hero, but a shared glow that touches all things. Every leaf, every stone, every ocean wave reflects it, bends it, holds it for a moment. In this way, light tells us that we are not separate from the universe, but threaded into it, each of us catching and releasing beams, part of a vast shimmering web. Think of moonlight on a calm lake. The water does not generate the glow, yet it holds it gently, letting it ripple across the surface. We too are like that lake, receiving light, reflecting it, becoming part of its journey. Stillness is not isolation, it is communion with what flows through us. And finally, light teaches us that even the restless can be a guide into rest. The stars do not stop moving, yet we gaze at them to fall asleep. The candle flame flickers, yet it brings us calm. Light, in its endless dance, shows us that peace does not require silence or stasis. It requires acceptance, The quiet awareness that motion itself can be a lull. Take a breath. Notice the light that surrounds you now. Maybe from a lamp, maybe from the faint moon outside your window. See how it softens the edges of the room, how it makes even shadows gentle. That is light whispering to you. It's safe. You can rest now. And so, dear listener, as we close tonight's exploration, I invite you to surrender to that stillness. The story of light has no ending, but your story tonight deserves a pause. Close your eyes and let the photons fade into dreams. Let their echoes guide you into sleep, where you too can move endlessly, yet feel completely at rest. Here on Boring Science for Sleep, this is the moment where words grow quiet and music begins to take their place. Soft, cosmic tones will fill the silence, like a starfield dissolving into sound. Allow them to carry you into the deep and peaceful night. Thank you for sharing this journey with me. If you've enjoyed tonight's story, remember that you're always welcome here. This is your quiet corner of the universe. Tell me in the comments, where are you listening from and what time is it there? I love to know the places and hours that our light touches. But for now, it is time to let go, time to rest, time to join the stillness that light itself suggests. Good night, dreamer. May your sleep be gentle, your dreams luminous, and your tomorrow filled with quiet wonder.